Hello everyone, we're on question 13 now of paper 1 from 2023. We've got a modelling question. So it says, on a roller coaster ride, passengers travel in carriages around a track. On the ride, the carriages complete multiple circuits of the track, such that the maximum vertical height of a carriage above the ground is 60 metres. The carriage starts a circuit at a vertical height of 2 metres above the ground. The ground is horizontal. The vertical height h metres of a carriage above the ground at t seconds after the carriage starts the first circuit is modelled by that equation. Find a complete model. Okay, so step 1. What are we told? We are told that the maximum height of the carriage is going to be 60 metres. Now, from this quadratic equation here, this is going to occur when t is equal to 20. Okay, so the maximum height will occur when t is 20. And that's because in this equation, we're going to have 20 minus 20 will be 0. So therefore, we can say that when t is equal to 20, our equation is h is equal to a. And the question tells us that the height at that time is 60. So therefore, a is 60. Okay, so that's our first step. We found out what a is. Next step. We're also told that at the start of the circuit, the height of the carriage is 2 metres above the ground. Okay, so that's basically telling us that when t is 0, h is equal to 2. So we can now sub that into our equation. So h is equal to 2 when t is 0. Okay, so that gives us 0 minus 20 squared, which is minus 20 squared, which is 400. So we have minus 400b. And then if I add the 400 over to the left, take the 2 over to the right, and divide by the 400, I get that b is 0.145. So my complete model for part A is that h is equal to 60 minus 0.145 times by t minus 20 squared. And that's part A. Right, part B. Use the model to determine the height of the carriage above the ground when t is equal to 40. Well, that's pretty nice and straightforward. All we've got to do there is just literally sub in t is equal to 40. So t is 40, 40 take away 20 is 20. We've got our a and our b from the previous bit, and that gives us a height of 2 metres. So it's only worth 1 mark there. Now, in an alternative model, the vertical height h metres of a carriage above the ground after t seconds after the carriage starts its first circuit is given by that alternative equation. So we've got a different model here for part C. Given that the carriage moves continuously for it says where alpha and beta are constants, find a complete model, a complete equation for the alternative model. Okay, so we've got to find do the same kind of thing we did in part A, but with this alternative model. So what do we know? We know again that the maximum height is 60 metres. Okay, now in this expression, the maximum is going to occur when the cosine of 9t plus alpha is 1. Okay, so in other words, 60 metres will occur when this is 29 times 1. So 60 is 29 times 1 add beta. So therefore beta is 31. So that's our first step. We've now found out that beta is 31. Let's use that initial other boundary condition that when t is equal to 0, the height is 2. Put that in. H is 2. T is 0, so 9 times 0. So we have cos of 9 times 0 add alpha, which is just cos alpha. So we've got 2 equals 29 cos alpha add 31. Take 31 off both sides and divide by 29, and you get minus 29 over 29 is cos alpha. So cos alpha is equal to minus 1. And from the graph of cosine, we know that that's going to occur here at 180 degrees is where cos is minus 1. So therefore alpha is 180 degrees. So our complete model for this other alternative version of the roller coaster's motion is h equals 29 cos t plus 9t plus 180 plus 31. Okay, now part D, it says give a reason why the alternative model is more appropriate. So the alternative model allows for multiple circuits. Because it's a cosine function, it's going to be periodic. So whatever it's doing, it's going to just keep on repeating, which is a better model for the motion of a roller coaster going around a circuit. Whereas this model is quadratic, negative quadratic, this one. So whilst it models what's going on correctly for part of the motion, it certainly is just going to do its own thing. It's not suitable for repeated motion. So it's the reason why it's more appropriate is because the second model allows multiple circuits. Okay, I hope you found that helpful. I'll see you in the next video.